Hello friends, I am back with my series of SIP, Story of Impressive Person. In the series of SIP, now I have invited another legend having experience of more than 25 years of experience in the design and consultancy for building electrically safe and reliable infrastructures in many countries, not in India, in many countries. And he is the first patent holder for world's first remote fault earth resistance monitoring system. He has designed a lightning protection system of Burj Khalifa, which is the world's tallest vertical structure. Apart from that, he has also designed lightning protection of tower, which is going to be the world's largest tower in the future. And he has also validated the largest Ferris wheel in Dubai for the lightning and earthing system. And he has been conferred with a special congressional recognition by a member of Congress USA for outstanding and invaluable services to the society. And he also received a Person of the Year for outstanding contribution by US Asia Business Forum 2010. He is not other than he is a very renowned person. He is a legend, respected, Honorable Sonjib Banerjee Sir. Welcome to the show. Pranam, namaste, and Shubhecha.
Same to you, sir. Same to everyone.
And I'm going to start my very first question. And actually the youth in India and across world would like to know about your brief journey of education, engineering, and employment.
I am son of an Air Force officer.
Okay.
My father was posted every 2 years. So after born in Pune, I have spent time across India.
Okay.
I studied in only Kendriya Vidyalayas.
Okay.
And after studying in Kendriya Vidyalaya up to 12th class, I did not want to do engineering.
Okay.
I wanted to do medical.
Wow. Interesting.
So medical in the sense, not MBBS, but I wanted to know biology.
Okay.
So I took BSc and I did chemistry, botany, and zoology for 2 years.
Okay.
So after that, my father said, no, I need to attend the common entrance test of engineering.
Okay.
I attended the common entrance test and got through the Government College of Karnataka, which was one of the third college that time. So having a government seat through CET, the college was exceptionally good. I had 3 professors who were Vishweshwara Award winners. Our college at that time had MTech robotics. So graduating from BRT College of Engineering, Mysore University.
Okay.
I graduated from Davangere. After that, my first employment was in Anand Control Systems. I was under Rakesh Anand, who was ex-TCE, and I designed the Mahi and Mukeria power control center, many motor control centers, many robotic centers. From there, I went to Indo-Asian. I headed many designs internationally in Indo-Asian. I was trained by Mr. V.P. Mahendru, Mr. Vimal Mahendru, and Vinay Mahendru.
Okay.
And I took over Inexpo as the head. Inexpo was the Indian Export Corporation, Dubai. And we had a very tough competition from China regarding brass. So my role changed from technical to understanding people.
Okay.
After Inexpo, I took over as the group general manager of one of the large conglomerates. I used to head about 7 countries, 7 companies. In that, there was a contracting wing, there was a heavy equipment wing, there was an electrical wing, and there was a hospital, there was food chain. But when all these operations were going on, I lost a person, a colleague, during operation.
Okay.
That is the time when I put my papers, I resigned, and I thought that I will start a company in safety and reliability.
Wow. That was a turning point, in fact. Kind of.
Yeah. So I resigned and came to India back. And I
Okay.
started a company.
What was the name of your company you started in the beginning?
The name of that company was Nalimo Engineers.
Okay.
And then we started through the same partners, SGI Engineers.
Okay.
And Mr.
That was,
Srinivas.
I think, Delhi-based company. Yeah.
He had Delhi operation, but it was based in Bangalore.
Bangalore. Okay.
But finally, when I was very keen in knowing why and not how, so I thought of starting a company which is a know why company, not a know how company.
Wow. This is the biggest strength you have, I think.
So I gave over all my stakes in that company to my partners. And I started a new company again from zero in 2012. And its name is Manav Energy.
Okay. Sir, my question, why did you decide to go to Dubai to start your Manav Energy? Or you started in Bangalore?
When I lost my friend in 2003.
Right.
I had most of the contacts in Dubai.
Okay. Okay.
So it was very easy for me to start in Dubai.
Oh.
So in 2005, I started Manav Dubai, but I started Nalimo Engineers India.
Oh.
So
and who is handling that company in India?
Actually, we all decided to close down that company and start SGI Engineers. So now that SGI Engineer is handled by one of my very, very good friends, Mr. Srinivas.
Okay.
Mr. Manish Desai.
Okay.
The sincere people whom I know in the industry.
Great, great. And coming to the very interesting question because when we talk about a patent, now tell me something about your patent of remote fault earth resistance monitoring system. Why the name is remote fault earth resistance? It is very, very confusing. I just want to understand remote fault earth, not earth fault.
See, when we are looking at an earthing system, this is very, very deep. If you look at the National Bureau of Soil Survey of India, there are over 1,760 types of soils. And these types of soils are dependent on its calcicity, on its sodacity, on its porosity, on its compaction, slope, moisture, many, many issues. So its variances at the time of stress changes.
Okay.
So we lump it to soil resistivity. So the dependence of soil resistivity at the time of stress is different for different types of soil out of this all entire 1,700 over 60 types of soil. And when we are looking at earthing and we want to understand earthing, we test earthing systems by taking a meter and injecting only 30 milliamps and trying to understand what is the stress developed by that 30 milliamps. And the voltage, the stress is divided by that 30 milliamp, and we say the efficiency of the earthing system is X. But that is not the true case. The true case of earthing is how did it behave at the time of fault. So at the time of lightning, it is a different animal.
Very true.
At the time of earth fault, it is a different animal.
Because the shape of power frequency fault and the lightning is quite different. You can't compare both. You can't compare apple with the orange at all.
So we needed a fault time earth monitoring system. At the time of fault, what is happening? Now tell me that if you want to measure physically, at the time of fault, what is happening? Is it possible to take an earthing reading at the time of fault? So it has to be taken remotely.
Okay. These are reasons the name is remote fault earth resistance monitoring system.
Fault time earth monitoring system. And it was very difficult to understand how to do it, because any signal which is grounded is grounded. But
Okay.
how to take the...
But I feel the fault level may be in kiloamperes. And the intensity, if we talk about the lightning, it is 8/20, or it depends on the wave shape. You can't predict that thing. Then how do you ensure that your equipment can sustain with that heavy current of any shape, any magnitude? How do you ensure? Because I think this is a tedious task as an engineer to design.
It took me 6 years to give a very excellent Faraday cage to the sensing device.
Okay.
It took me many thousands of failures to finally succeed. So after I devised this, then it took me 29 months of intense questioning by international bodies.
Wow.
And they granted us the patent. It was declared Nobel.
With that, I can say the failure of part of life. If we don't have failure, we don't learn. If we don't learn, we don't get success in your life. And slow progress is always better than no progress. And stay positive and don't give up. That is, I have learned from that answer about your patent.
Thank you, sir.
And, coming back to the very interesting question, when we talk about the largest, tallest building, Burj Khalifa, and I am lucky I am talking to a person who designed earthing and lighting of that tallest building in the world. What was your experience and how did you manage? Did you find any challenges doing the designing of that tallest building of the world?
John Walker is the MEP designer of the Burj Khalifa. So John Walker actually walked to me and said that, Banerjee, you please understand this. So when we were designing Burj Khalifa, we had to study how the statics will get built. So we looked at the mountains, we looked at the kind of statics which are possible. We looked at the different forms of statics which are possible at different heights, because you can understand the cloud level may be at 550 meters, 600 meters, but the tip is 800 meters. So the cloud can be below the lightning. You can have a reverse lightning or from top lightning. And when there were equipment on top of the Burj, there were anemometers, there were obstruction lights, there were various electronic equipment, which we call it, external delicate assets. So these are external delicate assets, whatever it is all at 820 meters above.
Okay.
So we all know that when a lightning is tending to strike and all the assets are that high, for those assets, every equipment is almost the same. There is no difference between that half a meter high or 250 mm high. And for us at ground level, we say that it is 1 meter at terminal. But at those heights, when every terminal is at 820 meters, another terminal can be 820.5 meters. It really doesn't make a difference. And if we change the direction of the lightning, then maybe one of them is nearer to the lightning than my terminal. So we had to really think on how to create, there was no other way, how to create a preferred point. So that whenever lightning is coming, and instead of touching these assets, which are extremely delicate, it will first break, it will first burn. Forget the electrical conductivity. So we had to direct the lightning to a tough point, which will actually take the lightning. And if you have seen now Burj Khalifa in 10 years have been struck 22 times.
22 times? Okay.
22 times. And I was on the tip 3 months back.
How do you record every time it strike at the Burj Khalifa? How do you record all these things? Is there any equipment to record?
Yes, there is an equipment record. There are two equipments on the Burj to record. One is a dual mezzanine equipment, another is a Phoenix equipment.
Okay.
So there are two equipments which has to record.
These equipments also record the intensity of lightning. What was the intensity or waveform?
The new equipment which is getting fixed in next 3 or 4 months will record the intensity and the waveform.
Okay. And how many months did you take to design Burj Khalifa? What was the total time taken?
See, whenever we design a thing, we have to start from the point that I don't know. So remember that time Burj Khalifa was not there.
Okay.
You know, so it was only an idea.
Okay.
And so we had drawings. So we were only doing math. So those large number of math had to be done. There are many high voltage engineers who look at high voltage deeply, but lightning is a different issue. Today, fairly we can say that we have started understanding the small things about lightning.
Basically, we can say you have become doctor of lightning.
No,
when
we
you
have
start
started
understanding the behavior of your patient, only doctor can understand that thing.
I'm a student of this field, and the time epsilon, means the exact time how the upward streamer start, no one knows yet.
Right.
Everyone can do a math little later, but the initiation is still unknown.
You are a student, but you are a senior student. Okay. Coming to your experience about Creek Tower, how it was different from the Burj Khalifa so far that designing is concerned?
As Creek Tower is not yet made, it is on paper. It is an IP, so I will not be able to divulge too much on Creek Tower. So it is better to take the next question if you don't mind.
Okay. Okay. Now coming to the Ferris wheel of in Dubai, can you tell me something about very interesting thing?
Yeah, in Ferris wheel, these are all big glass houses.
Okay.
These houses are as big as a large drawing room, and there are 48 such houses, circling. The diameter of London wheel is maybe around 150 meters, but Ferris wheel is 220 meters.
Okay.
And it takes almost 1.5 to 2 hours for the thing which is on top to come down. So by that time, if there is a storm, and if it grows, and if the lightning starts, how safe is that wheel? So we created the Ferris wheel in EMTP RV software inside the simulator.
Okay.
And we created every component of that house, including its rims, its shims, its joints, its wires, everything up to ELV system inside the simulator.
How difficult was it to bring the down conductor from that Ferris wheel?
There is no down conductor in Farid's wheel.
Okay.
So it is the structural system which is used.
Okay. 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 Okay.
The down conduction, yes, there are some brushes to, between to shift the current from the moving part to, so there are no down conductors.
Okay.
So all validation which was done is at the time of lightning. You see there are 96 cords which are coming to the center. Now, as the cords are coming closer and closer to center, the distance between two cords is reducing.
Okay.
But the stress, as the length of the cord is increasing, the stress is increasing. So there may be intercord spark. So how do you, break down the lightning current in so small portions?
That was a big challenge.
That was a
And
challenge.
you could overcome it.
Yeah.
Okay. Very
Every
great.
design is very challenging.
Coming to the prestigious award you get, Person of the Year award you received. How did you receive? But can you tell me some interesting story behind that award? Person of the Year award.
The most interesting thing is about this is I don't know why I received it. I suddenly got a message that I have to go to LA.
Okay.
I was nominated. I had no idea. Of course, I had finished that time the Burj. I think that is one of the key reasons. I also protected 21 palaces in the Middle East.
Okay.
They are all mission critical and where we cannot go wrong. So we cannot assume, we cannot think what is in general practice to do something which is generally available. We have to go beyond standards.
True.
Standards are general guidelines. But as an engineer, we have to understand the assets, susceptibilities. We need to look at it and we need to look at available engineering, intermingle, mix, use the advantages. This is what we do, but I really don't know why I got the award. No one told me.
Sir, very small question to make. When you say sometimes you have to go beyond the regulations and whatever written in the regulation, don't you think it is very challenging to make the engineering department for which you are doing that design to accept the design that is beyond any regulations and any guideline, any book? How do you convince that utility person to accept that design that is not written anywhere in any regulation?
It's very simple because these projects, what we handle, the engineers sitting there are all doing world number one project, the first time in the world.
Okay.
If we had to make everything within the regulation, Burj Khalifa wouldn't have been made. So I'm sure that today's understanding of engineers is very deep. Various subjects are already available in Google. It is about openness of mixing technologies. We are not saying we are going beyond the book. We are saying that there are many books. And how do we intermingle each book and come not as per a book, because my requirement is safety. My requirement is not to follow a regulation. So if I have an asset, then my aim as an engineer is to give safety to that asset.
But
so
I think in India, it is difficult to change the mindset of the person working at the top level because they always try to look at the books, guidelines, regulations. I think so.
I feel that people who are at the top, they're on top because they are willing to change. That may be the case internationally. In India, I have done few projects and everywhere I have seen very, very amicable people who are ready for change.
Okay.
If we are not ready for change, then we are only going to be history. So
Okay, can you cite one examples so far Indian scenario is concerned related to a project where you find good amicable people who could understand your philosophy of designing? Can you cite very small examples?
Yes. In fact, we hardly did any small project, but when we were designing Rohtang Pass, Atal Tunnel is designed by us.
Okay. Wow, wow.
So when we were designing Rohtang earthing systems of Rohtang Pass, we had to do earthing at minus 30 degrees.
Minus 30
Now,
degree.
so where is earthing at minus 30? Everyone talks about 0 degree. Everyone talks of frost line. Why? Because the moisture turns into ice.
Ice.
Ice
You're
is
right.
insular. So how can you go negative degree centigrades? But we designed. And the BSF heads were open to change. So we put out, we looked at various forms of stalactites and stalagmites. We looked at various conduction bands. We looked at elements which can grow inside the pores of the rock.
Wow.
And we converted few rocks into conduction bands.
Wow, wow, wow.
And these were all people who were at the very top. And this is our Rohtang Pass, one of the finest examples of project in India.
Wow, wow, wow. Great. Coming to very interesting part about the publication and your teaching, that I know that is very close to your heart. You love to teach, you love to guide people about safety and earthing. I have also attended many lectures of yours in CBIP and through webinar. How did you come in contact with CBIP and when did that journey started? And what was your very first publication that you still remember?
No, CBIP I came to know through one of my friend, and when I went there, Mr. Kanjilia was so welcoming. The then the head of CBIP, and it is actually due to CBIP who understood what we were trying to say, and I'm grateful that they thought that I should be one of the people who lecture. I have given few lectures in CBIP. It has greatly helped me because the students of CBIP are also very senior engineers. They attended my lecture and they came to know. I was very fortunate to meet you, Dr. Rajesh. Regarding my one of the papers, I think one of the first papers I published was Modern Aspects of Electricity.
Okay.
Before earthing. Yeah. And in CBIP, yes, I talked about the very understanding about, people think current is movement of electrons, which it is not. So I tried to explain in CBIP a different dimension. I'm not saying it is not. I'm saying that it's a different dimension to look at electrical engineering. It's a dimension which is full of physics. So
I still remember you are expressing that thing by raising your finger 1, 2, 3 like that. Still, I do remember that lecture. Okay. Coming to very interesting question, because what do you think? In India, people are ready to implement the right, adequate earthing, lighting, and grounding systems. If not, what is the reasons behind that? What do you think? What is your view on that?
See, people have to understand that earthing has 5 facets. Suppose we need to operate a protection system, then the energy has to come back to the source. Suppose there is a source which is not in the circuit like lightning, the earthing acts as a dilution mechanism. Similarly, the earthing is also a shielding mechanism so that the external environment doesn't disturb. It is a reference system.
Right.
So people who understand, who wants to provide this, they definitely look at earthing. But for people where the earthing is achieving 1 ohm, for achieving rod in a hole, for doing what probably the number of earth pits to be made, who are not looking at why the earthing is being done. Suppose you are creating 40 pits. Why are you creating 40? Why not 39 and why not 41? What do you want to achieve by creating that 40 pit? Is there any organization who can give you the same result in 2 pits? Because your duty is not to create 40 pits. Your duty is to trip the protection system. Your duty is shielding. Your duty is, those are the things what you want to achieve. So if you can do a thing in completely different fashion, not even creating pits by doing something else.
And sir,
Then,
what your view on one location, one earthing, the people that don't understand that concept in India? What your message for such?
Anyone who is result oriented, when I say he knows why he is doing earthing, I have seen those people are very open. But anyone who wants to do know how, follow, then they follow standards. Then they follow number of equipment. Then they follow what is written in for last 40 years. So we have both types of people in India. But in a changing India, like young people like you and youngsters, I'm sure India is going to change.
Okay. And now I would like to know about, can you elaborate something on your project you are taking, like load flow study, short circuit study, panel feasibility check, breaker feasibility check, root cause failure analysis, lightning transient analysis, EM analysis, compatibility and induced voltage assessment on control cables. Do you think the people are ready to do all these things in India? The people have changed to go for all these kinds of studies now. We are ready for such study, or it will take time to go for all this study?
It is like asking, are you ready to survive? If we are not ready, if we want, like we both are now speaking to each other, this is our steady state. But before you were coming to this interview, you were in a different mood. That was your another steady state.
True.
That steady state is not equal to this steady state. And when you were changing, you were in a transient. So life is full of different steady states and transients.
Wow.
Change.
What a great example.
Yeah. So if we do load flow analysis, now people take one circuit and they run things and they say this is load flow analysis. But load flow analysis has many steady states. So load flow analysis has to be done in many steady states. And the change of steady state is a transient.
True.
Transient analysis has to be done. So if you really want to give worth to your money, suppose you have spent crores of rupees, and you want the crores of rupees which you have spent to last for 30, 35 years and not undertake maintenance within that time, then you have to design well, because safety is achieved through design. It cannot be achieved through component.
Sir, what are you doing under that breaker feasibility check?
Now see, when we are looking at a breaker,
okay.
So what does a breaker do? It either makes or breaks.
Right. Under all conditions, from no load, full load, and short circuit.
And under all phases.
Yeah.
From 0 degree to 90 degree.
Right.
Okay. Yeah. So how many operations the breaker has to work? how many of times it can break, it can close and open during a fault time.
Okay.
How much time the arc is going to last? Will the arc last if it is completely open also? Will the arc ionize the air so much that the arc will persist? During this time, because heavy current is moving, there are thermal issues, there are mechanical issues. Can it handle the mechanical issues? So these are
Interesting. Very
the
interesting.
electrical, mechanical, and thermal issues at various operating principles at various phases.
Are you using some particular software or some simulation things to perform that study at site? Because that can be performed at site only. It's not a theoretical thing.
Today's science allows us to map. When I was integrating 300 megawatt of solar to the Saudi network, then we had to do transient analysis of the entire Saudi network. So we could model the whole network in our system,
Okay.
in the simulator.
Okay.
Like that, when we were designing Riyadh Metro, then we had to run 1,200 rectifiers simultaneously. Now, physically, when you want to stand there, you can do nothing. So you can only model it in your simulator,
Right.
Validate each model, and then make it, break it, short circuit it, lightning it, whatever you want in the system. So it is possible to simulate.
Okay. Now
we use EMPR, we use PSCAD, we use CORCAD, we use CDEG, we use many simulation platforms.
I am surprised. How do you handle so many software you are using for different study? How do you manage that thing?
It is easy to take out the output of one software and put it as input of another software. The thing is, you never take the result of a software for granted.
True.
You have to validate the physics. So that is why common sense is more important than result.
But I feel only legends like respected Sonjib Banerjee can do that thing. Okay. Now I would like to know about your social life, family, and future plan.
My wife's name is Sonjib Banerjee.
Okay.
She has been in Intel, and she, after working decades in Intel, she is a direct student of San Petroda.
Okay.
So she took over as a managing director of my company, and she heads the company operationally. I'm into R&D and development.
Okay.
I'm having two daughters. One daughter has done again her electrical engineering, done her master's from Italy and Melbourne.
Wow.
I have another daughter who was doing aerospace from Sydney. So we are a 4-member family, 4 engineers.
Great. All are engineers. Then tell me one thing, when all of these engineers sit at the dinner table or lunch table, how do you interact with each other?
Father, mother, and daughters.
Okay. Okay. And now, without taking much time, because you have given me your precious time out of your very, very busy schedule. Now, before we end this very important conversation and dialogue, I just want to know what your advice for the youth, your success mantra, would you like to narrate to the youth? Please give that brief so that the people can work on that particular direction, and the advice given by respected Sonjib Banerjee, so that they can also be like you, or at least 50 or 20% of caliber you have, they can achieve.
I would say that I think I have failed and failed and failed, and in this failure there is experience.
Right.
So we have to come out of this following, it is not about walking the trodden path. It is about waiting and seeing, why am I walking this? You know, to question and to understand. I'm telling you, whatever I want to see, that the answer is already there in Google. So more important is the question. If you question, you have the answer. But if you don't question, and we keep on following, then we will only follow various standards written by international people. We will not create our own science like Aryabhatta.
True.
It's time that India creates its own science.
And I would like to end up my dialogue with your quotation only. The problem is that we don't know what we don't know. That Sonjib Banerjee Sir usually says. And with that quotation, I would like to say thank you once again for accepting my invitation. Pranam, Dhanyavad, thank you very much, sir. Thank you once again.
Thank you, sir.